Hello everyone, welcome back to my channel. I'm Gowda.r, pursuing my education at Sri Venkateswara College of Engineering, Bengaluru. Today's subject is based on operating system and the topic is process scheduling. So let's understand the topics. Let us gain some knowledge about process scheduling in operating systems. Process scheduling is a fundamental concept in operating system design that governs how computational resources are allocated to various processes running on a computer system. It ensures efficient and fair utilization of the CPU, memory, and other system resources. Introduction to process scheduling. First step is process creation. When a new process is created, the operating system must determine how to allocate resources and schedule its execution. Second step is resource allocation. The scheduler decides which process gets access to the CPU, memory, and other system resources and for how long. Third step is fairness and efficiency. The scheduling algorithm must balance the goals of fairness through output and response time for all processes. Moving on to the next topic, CPU burst and input-output burst. CPU burst. The period of time a process spends actively using the CPU performing computations. Input-output burst. The period of time a process spends waiting for input or output operations such as reading from and writing to a file or device. Alternating cycles. Process typically alternate between CPU burst and I/O burst, creating a cyclic pattern of resource usage. Let us know about CPU scheduling criteria. The first one is throughput, the number of processes that can be completed in a given time period. Second one is response time, the time it takes for a process to start running after it has been submitted. Third step is turnaround time, the total time a process takes to execute from submission to completion. Fourth step, fairness, ensuring that all processes are given on a CPU time. There are three types of scheduling algorithm in process scheduling. Let us know one by one. First one is first come first serve, FCFS scheduling. Simple implementation. FCFS CPU scheduling algorithm where processes are executed in order they arrive. No starvation. FCFS ensures that no processes is starved of CPU time as they are guaranteed to be executed eventually. Poor response time. FCFS can lead to poor response times as short processes may be forced to wait behind long running processes. Lack of fairness. FCFS does not consider the varying resource requirements of different processes, which can lead to unfair scheduling. The next scheduling algorithm is SJF scheduling, which is nothing but shortest job first scheduling. Here, we minimize average waiting time. SJF scheduling aims to minimize the average waiting time for all processes by executing the shortest job first. Moving on to starvation possible. Long-running processes may be starved of CPU time if shorter jobs are continuously submitted. Challenges in prediction. Accurately predicting the CPU burst time for each process can be difficult, affecting the algorithm's effectiveness. Preemptive shortest job first, PSJF scheduling. First one is preemption. PSJF is a preemptive version of SJF where the currently running process can be interrupted and rescheduled. Optimal scheduling. PSJF provides the best average waiting time among all scheduling algorithms as it always executes the shortest remaining job. Complexity. The need of to consistently monitor and update process burst time makes PSJF more complex to implement. On to round robin scheduling. First step is time slicing. Round robin scheduling divides the CPU time into fixed length time slices and processes are executed in a circular order. Fairness. The round robin ensures that all processes are given an equal share of the CPU, improving fairness compared to FCFS. Context switching. Frequent context switching between processes can be introduced overhead and reduce overall system performance. Time slice length. The choice of time slice length is important as it affects the balance between responsiveness, and throughput. Priority scheduling. Under priority scheduling, there are preemptive priority, non-preemptive priority, dynamic priority, and starvation. Let us know it one by one. Preemptive priority. Higher priority process can interrupt and preemptive lower priority processes. Non-preemptive priority. Lower priority processes must complete before higher priority process can start. Dynamic priority. Process priority can change over time based on factors like waiting time or resource usage. Starvation. Careful priority assignment is needed to avoid starvation of lower priority processes. Process schedulers are fundamental components of operating systems responsible for deciding the order in which processes are executed by CPU. In simple terms, they manage how the CPU allocates its time among multiple tasks or processes that are competing for its attention. Considerations in process scheduling. First point, real-time requirements. Certain processes such as those in embedded systems or safety critical applications may have strict real-time constraints. Second point, resource availability. The scheduling algorithm must consider the availability of system resources such as memory, input-output devices, and network bandwidth. Third point, system load. The number of active processes and their resource demands can impact the effectiveness of scheduling algorithm. Fourth point, adaptability. Successful scheduling policies must be able to adapt the changes in workload and system conditions over time. I hope you guys gained some knowledge about process scheduling. Please do like, share, and subscribe to my channel. Thank you.